Hello and welcome to the 5th video in the Game of Active Directory Purple Teaming Exercise series. In this series, we are learning how to attack Active Directory and also defend by having alerts being generated in ElasticSIEM. This is all set up in the Ludus lab environment, and I have videos in this series as well that you can go and watch and how to set it up. But our main objective today is to attack the Game of Active Directory machine and hopefully learn something about how we could have defended in this environment. So this is great if you want to learn ethical hacking and also be a good defender, where you can actually see where you might look for things if an attack like this happens. Ninja Hack Academy is the game that we are attacking, and we also have Elastic Security, so we'll be generating some alerts that will be coming in here. But if you want to set it up, I'll have links in the description and also in our companion GitHub page that I deployed earlier. Going forward, I will have something like this at the beginning of every video where you'll be able to see what we're working on and also some show notes that you can see. I'll push to the repo as well. But today we're going to do initial recon, where we'll start by performing an Nmap scan, identify some targets, then we'll identify SQL injection. There's a machine that is SQL injection, so we'll walk through the process. I did this before so that it's easier to record these videos. And then we'll gain shell to that machine using a command and control server called Sliver C2, and then we'll escalate our privileges from our user that we'll get into to become system. And as you can imagine, if we have a decent EDR in place, we should be able to see some alerts, and a lot of alerts should generate here. So this is going to be fun. It's going to be a longer video, but definitely worth it to watch until the end. Otherwise, let's get started. I'm connected to my Game of Active Directory machine using the actual machine. So the first thing that we're going to do is going to be an Nmap scan. The way that we're running this is we need to specify the entire subnet. My Game of Active Directory is on 10.10, and I can scan the entire subnet and save all the results to all ports.nmap, and this is going to be in my Game of Active Directory folder. That way everything is kind of organized. This P here says, hey, scan using all ports. This can be noisy if we were the security onion or something that is monitoring the environment, but we don't have that here, so I'm not worrying about that. I'm more concerned about endpoint detection. SC, we will run default scripts. This can definitely get us caught, and also service version. If we enumerate service version, we might send certain network traffic to this machine that's enumerating for versions, and that might also generate some alerts, but we are not too worried. This will just scan and give us all IP addresses and all ports, and when you run this, it will take a while to go. So I already also have some results here, but called in initial nmap.nmap. So what we can do is we can cat that file. Maybe let's pipe it to less. Ideally, what we want to do is maybe target specific ports. That way we don't end up like scanning everything and taking forever. We can target web applications to begin with and kind of figure out how many web applications are there. Maybe scan for live hosts, but I scanned everything because I was being lazy. We see a host on 21, 3389, and this shows me that it's a Windows machine, and we don't have any web application running on this machine. So if I were doing this in an OSEP or something like that, OSCP, I'll definitely move on, because most of the time initial access in the CTFs like this is going to be on port 80 or some application that is not native to Windows. For example, here I see port 80. This is on .30. So this is interesting. We will open our machine here. All right, it's a default IIS page. We'll keep this one in mind here, because later we might want to run a tool to bust some directories here. But this is also a finding, because they should have disabled this default IIS page. But anyway, we'll move on to the next one, just in case. But also on the same machine, I see default ports for Windows here. But this is a domain controller, which is kind of interesting that they have this default page still open. Usually people disable that. Otherwise, port 8080 here, it shows me that we are running Kerberos, as you can see, and it's a DC, and we don't have any other weird services. No, but most of the time people don't run other services on domain controllers. And interesting enough, we have RDP open on 3389, so we'll probably use RDP sessions later if we break into that. So let's keep going. And here I see another domain controller on port 88. This is 31. But I don't have port 80, and I also don't have any other services running. If I scroll down, so that was 31. Now come to 32. I see port 80 is open, and it's another Windows machine. 3389 is open, so we can RDP to that as well. And this is 32, so let's go to our browser and visit it. We notice that we have this ninja hack.lan. It's a machine. It looks like a academy, so somebody's running a school. This is the home folder. What I like to do when I see this is I look at the versions. This is at 2024. I'm looking, is this running WordPress? And if it's WordPress or Drupal or whatever, that's usually what we try to see as easy wins for CTFs. But here I see a list of students. So we'll go to that section and let's see if we can interact with a list of students. Okay, in a new tab, we can search by first, last name, and also by team. So first, what if I search for N? I know Noah is here. Is it actually case sensitive? Okay. Okay, so looking at the site here, we can search for students like I showed you. But if you look in the URL, you notice that there's a comma order by equals first name. These are actual SQL queries being shown in here. So I can just ask ChatGPT here. This is actually a good indicator that this is actually vulnerable to injection because they are running SQL queries and I can see them in the URL, which is a problem. I think ChatGPT might not like us, and if it doesn't, we'll go to Perplex. All right, actually ChatGPT is working. And I asked it like, hey, how can I test this? Testing SQL injection vulnerability should be done cautiously, simple syntax. So like that. All right, so as you can see, this is the order by. I don't suggest running ChatGPT and feeding ChatGPT or clients that you're pen testing or anything like that, but you can use ChatGPT with something similar to just quickly figure out how to do these. Because as you can see, this is a simple injection vulnerability. If I run this, I should see all of the users if it works. Okay, so that didn't work. So after looking at that, the same site that we have looks just like how this guide is talking about. Like, you know, this time they had category, but in ours they are searching. So we can just append one is equals to 1 and see if things would work. So you can play with these injections here. And after looking around, I found out that we can just take that same URL and run it via SQLMap. So we can ask ChatGPT here. I think we already have one. Yeah, example command, SQLMap, order batch DBS. I think this one should work. So we're already interacting with the victim and we're running SQLMap, a tool that we barely understand. So as you can imagine, we might get caught here. All right, SQLMap, URL, batch DBS. All right, well, it appears that you have provided tainted parameters value search string is equals to. All right, so in our search string, we did not actually give it a search string. ChatGPT did not fix that for us. So let's give it, let's say we want to search for Z and order by. This should actually search. We might also want to make sure that we get maybe OS shell. Let's test OS shell and see what that looks like. And this just means that appending -OS shell at the end. Not those. We're getting all kinds of examples here, but we want the SQLMap one. So if we just did that, yeah, this time they added search string of John. So this one should work. It's the same as the one that you see on our GitHub. But now coming back here, this is actually querying our databases. I see that we have model, MSDB, and this is probably the temp database. So SQL injection is working by just looking at these. While you may not be allowed to use ChatGPT in some of these exams, you will be able to use this if you know how to properly use it internally. So tempdb. Okay, so these are the databases. So injection vulnerability works. This time, let's get a shell. Let's just attempt to go straight for shell and run the commands. It's the same thing. We went to the injectable one, but this time we are looking for John and order by name. And we want a shell to be given back to us. And this will definitely trigger something in our alerts in Kibana here. Was running SQLMap and getting a shell, that means that the SQL service is going to interact with the command line, and the chances of that SQL service spawning the command line are very, very low. In fact, it shouldn't be doing that, and that's probably what will get us caught here, and we'll verify that in a little bit. But here we're being asked, do you want to values? Sure. I'm just accepting all the defaults. All right, so as you can see, we have OS shell. Let's just do something silly. We're going to run the command who am I. We know that this command definitely gets us caught. You have seen that on this channel before, but let's just run it anyway so that we can see who we are. And also, this will give us an idea of how fast is this terminal is. If it's not too fast, what we can do is we can intercept the request with burp suite. We can ask to not get these results back because it might be unusable sometimes. But right now we just ran who am I, and we are retrieving some data. So that means that we are running commands on the terminal, on the machine, using the SQL service, whatever we are using here. In this case, is this NT authority? All right, so now that we know we can run these commands, let's weaponize this a little bit. Let's weaponize it so that we can actually see things. One, we can add -- threads that I had added in my notes here so that we can have the maximum number of threads faster. And then after that, let's go and set up a Sliver C2 payload that we'll try to upload through that. Then once we upload our payload, we'll get it kicked off. That way we can have a command and control server that can actually help us with all the interactions with the machines. So what we can do is we can just look up documentation for Sliver. That way we figure out what is Sliver C2 and how does it work. I have this document here. It's very, very detailed. It's not by me, by the way. It's learning Sliver C2 and beacons by this person. I'll link it down. And the way that this will work is it will show you everything that you need from starting Sliver and also how to generate beacons. Generating the implant under beacons. So in order for us to generate a beacon, we're going to copy this, generate beacon, and then we'll start our Sliver, and we'll also start our listener. I want an HTTP beacon instead of MTLS. But okay, we are not a system. We're NT Authority Network Service. That's a useless service, by the way. But that won't get us anything. So let me start my Sliver client. Okay, sessions. Let me just check to see if I have any sessions, beacons. Okay, do I have any jobs? Okay, I'm listening on HTTP. So to start with HTTP listener, you just type HTTP and it will actually start an HTTP listener, which I already have here. So it's going to complain that the port is already taken in a second here. Then after that, if I say jobs, yeah, I still have my HTTP listener. That was complaining that it's already running. Here, I just copied that. I want to create my beacon, but mine is going to be saved in my payloads folder. Now that it didn't autocomplete, I would just do such home/Kali. That way, I know that it's a full path. It's going to be an executable 64-bit architecture. It's a Windows. This one is going to need to call back to my Kali. So 10. What is my Kali? IPA 99. Okay, so that's where we need this to call back to. One of these 10 to 1099. But I don't want MTLS, I want HTTP. You can use MTLS if you want as well. I think that should be it. And let's generate the beacon implant. And once this is generated, we need to upload it to the victim using our OS shell. This is where the fun actually begins. We need to upload it using this OS shell. And in order for us to run the commands, as you can see, we already ran who am I, and it works. So we can technically upload it using any other tools that are out there. I'll add a section here. Upload using SQL shell, whatever it's called. I'm going to use setutil because I'm trying to avoid PowerShell, but I'll just say setutil is a tool already on Windows, which is living off the land, and people recommend it. But of course, defenders already know that C2 is already being used, so it will definitely get caught. I'm doing this for theatrics here, so you can see all kinds of tools that we run in CTFs that are just noisy. I know this one will get caught. But C2, I'll say upload from a HTTP server a file called backup.exe into C Windows tasks backup.exe. Let's see if we can name our Sliver beacon implant backup.exe. That way, it kind of looks like a backup tool that we put out there. So come back here. It says that it saved it as stalegossip.exe in my uploads folder. So what I mean in my payloads folder. So see the payloads. I can come in here and say, oh, this stalegossip.exe, I want it to be named backup.exe. So let me remove my backup.exe that's already here. Yeah, let's remove it. Then copy that to be backup.exe. All right. So now that we have it in our payloads, you can host this however you want. This is just another way that I learned through CTFs. And we're going to launch a Python 3 -m http.server on 80. All the things that we have learned from Hack the Box, Try Hack Me, and stuff like that. Now we're applying it here, which is also a good way for us to know whether or not this is a good idea. I already know Python 3 simple HTTP servers do not behave like regular servers. They're really janky, but we're going to try to have it get caught here and to see if this shows up in the logs later. Otherwise, we will probably need to do this properly. So I have it on 8080 hosting that. Now, all I need to do is figure out if C2 will download from my Kali from 8080 and also upload it to tasks. A couple of things to think about is when you host your Python 3 simple HTTP server, if somebody can access this file without any authentication, you're exposing this to the whole world, which is probably not a good idea for OPSEC, because people can see your implant and your implants already have your information, and the red teamers don't want to get caught and get your implant in a article somewhere because of this silly thing here. So just calling it out there. Otherwise, we're doing it anyway because CTF speed. Then paste it. So C2 is going to download. We'll know that this worked because in our HTTP server, we should get a kick that says it was downloaded. So I'll just say yes. Oh, I should have added threads to this. That way it should have worked. Let's check our HTTP server. All right, as you can see, we did get a GET request and it's 200. Just to be sure, I'll let this slowly upload. I'm thinking there might be some delay. So instead of just rushing through it, I'll let this finish here. C2 will tell us like, oh yeah, it worked. So while we are uploading, we are now at this step here in our document, upload a shell. And once we upload our shell, we'll be anti-system network, which is that silly, unusable. So we need to escalate our privileges to some user or somebody better. So that's what we will do. We're taking the shortest cut, and C2 is still uploading. You might be wondering, what is happening in our EDR? EDR should be complaining. We have done a lot of bad things. Let's refresh this. It has been not giving us anything. Oh yeah, we have stuff. So remember, let's hold that thought. We are uploading our backup, and after it uploads, we're going to execute it. And to execute it, we just need to point to this binary here directly, and it should execute directly. Otherwise, but let's let it upload. What did we trigger by running SQLMap and getting a shell? A lot of alerts, high alerts 6, we have 4 low. So let's first look at the first one at the top here. And I'll get me out of the way. As you can see, this one is execution via MySQL command shell stored procedure. It identifies execution via this stored procedure. Malicious users may attempt to elevate their privileges by using this is what we have done a lot. If you go through any of the training like Hack the Box, whatever, people who give training out there, they'll tell you to learn this to attack SQL servers. So how do we defend it? We have these rules in place to catch that. Specifically, what they saw is the process that ran, we launched cmd.exe, and who was the parent process for that? SQL Service. What are the odds that SQL Service will be launching cmd.exe from the terminal, unless if you're doing some other like procedures in there that are needed? But specifically, what did we run? Oh, this is the cool part. We ran command prompt to execute set-util, and we uploaded this here. So the defenders will be able to tell right away exactly what the command ran and where the file was dumped. In this case, we put it in tasks, and it's named backup.exe. So you get busted out of the box. Pretty cool though, if you were a defender, to see things like this. Again, this also quoted here, stored procedure. That was the second one. That whoami command that we ran earlier, bad news. Here it is. We ran whoami and identify suspicious use of whoami, which display user group privileges of the user who is currently logged in. So running whoami directly on a Windows machine from a SQL service that launched command that was launched, command prompt that was launched by the SQL service, kind of silly and easy to detect, as you can see here. Otherwise, we have a lot. Okay, that's still whoami command execution via my SQL service. All right, here was one. All right, so everything that we've done so far, bad OPSEC, bad. You saw it yourself. Otherwise, let's go back. All right, folks, we're back, and as you can see, set-util worked. I highly suggest you put the threads here so that yours is not as slow. Mine is not, it's slow. It's not that bad. Like a couple minutes, I just had to wait here. Otherwise, now that we finished with set-util and we already looked at the alerts and we know it will get us caught, what we can do is let's execute our file. And if all went well, we should be able to get our callback in Sliver. So just say yes, and then we just watch our Sliver here. All right, so connection timed out to the target viewer. SQLMap is going to retry the request. So whatever we did here, the connection died. I bet our EDR is causing problems there. Let's check for beacons. Oh yeah, there it is. So we already have EDR, Elastic, but I did put it in just detect mode. I'm not stopping it. The default Sliver payload will definitely get eaten up by a decent EDR, so you need evasion there. What I'm more interested in is just making sure that it gets caught and we can see it. Otherwise, we'll not be able to demo it here without bypassing it. This is not a video about bypassing things, so that's why we're doing this. It looks like we got 2 here. Let's see beacons. So we actually connected twice, which is good, and we're still the network service, anti-authority service, which is not ideal. So what we can say is, let's say use 7.1. That way we can just use one of these, and we are now interacting with our victim machine. Otherwise, once we do that, oh, am I getting more beacons? How many times did I execute this? It looks like my my SQLMap keeps retrying, so I gotta make sure that it doesn't do that. Okay. Yeah. Otherwise, I'll probably keep getting more, and I'll stop this as well. All right. So back here, how many did I actually ended up getting? Just 3. I can type clear to clear this. Oh, I might have made a mistake. I keep getting beacons. I hope it doesn't keep retrying and retrying and retrying. That's gonna be bad because it might crash my system. All right. So now we are in a beacon. If I say interactive, this will get me a session. And okay, let's look at the tasks. All right, so we should have a session. Yeah, so I typed interactive so that I can get a session. And again, this is another bad OPSEC as well for E, because this will definitely get caught, but use for E 44. All right, now we're in a session. We're going to do an execute. -O who am I /all. This way we can compare. We ran who am I earlier through the SQL. Now we're also going to run who am I /all. So we can really see. We're entering our network service, but this time we are looking for a way to escape. And the easiest way is if any of these attributes are set, like, here, privilege information, you're looking for like genetics, bypass, impersonate, authentication. Okay, so we'll target the SE impersonate privilege here. This one here, we can use a lot of tools. If you go through the OSCP or OSEP, you will notice that already a lot of tools out there, including Print Spoofer. This is a very, very common way of escalating privileges easily on Windows, Active Directory, or hack the box machines out there that you might see. It's also set sometimes, not all the time. And here I'm going to use Print Spoofer. You can Google how to properly do this for yourself. I'm going to use Print Spoofer. You can download Print Spoofer from any of the GitHub repositories out there that you can find. So we will need to upload this to the machine using our Sliver implant session that we have. And again, we're going to put this in the tasks folder because we like the tasks folder. It's already a folder that we have interacted with. So in order for us to do that, we're going to do this, upload from my Kali Linux machine in my payloads folder. And I want that to output it to C Windows task printspoofer.exe. That way we can actually execute Print Spoofer and get a system beacon. So that's how simple it is when you have that privilege set. And again, this is definitely going to get caught. We're uploading a binary to the tasks folder. Maybe we should get a different location, like in the user space or anywhere else other than the tasks, because most people watch this folder. But hey, we're here for theatrics. We want to show you that this is really bad. That way we can all learn here. Otherwise, we're going to do that, and this is just the upload command in Sliver C2, and it's saying it wrote it there, but we can also check using the execute.o, like, hey, is Print Spoofer in there? Otherwise, it's saying that it wrote it there. This was quick, so assume that it did. Let's go and shell. This is a bad obsec. Are you sure you're in a doubt? Yeah, let's go. Don't mess with me. So we're doing even the worst things. We are going to actually directly execute the commands here because someone here doesn't know how to run the execute command correctly for now. So now let's go to CDC, Windows, tasks, dir. Here's my Print Spoofer, and here's my backup.exe. So let's just run it, but this time we're going to just run it directly without the execute-o command. We should be able to do that as well, but we're into bad OPSEC today, so we are doing everything the wrong way. So we got in here. We are not in a doubt. I want to see what does this actually do on the alerts. We're going to see a ridiculous amount of alerts by just getting into the shell here. We're lighting up EDR, but for now, let's just run that. And that should definitely execute it. As you can see, we found impersonation privilege. Created a named pipe. Process creation, okay. Let's see if we can exit out of here. Control C. Reconnect to Sliver. Beacons. All right, we did get one after we left. All right, here it is. Here's our beacon that came back as NT system. So use E0. All right. Interactive, because we did that earlier. Use, yeah, I mean, we're already NT system anyway. So use 2.3. Where am I? NT system. Okay, so with Sliver, we can do privilege escalation and persistence. We are a system right now. We don't know where the flag is, but we should be able to see, like, okay, let's go find our flag like we did earlier. This time we did it again. CDC, users. Let's find out who are the users here. We have administrator and local user. Oh, I guess we don't have a lot of users. So let's go to administrator. in DIR, CD desktop probably. We always put flags on the desktop. Type flag.text because we are doing a capture the flag. All right, so you touch my potato. So they did want us to do that privilege escalation. Anyway, this was a lot of really bad OPSEC and everything in between. So one thing to know is dropping into the shell is definitely a big no-no. We even get a warning there. But why not talk about it when we can see it in the logs so that we know why it's really bad. So let's go back here. We generated a lot of alerts. Right now we had 6 and 4. Let's just refresh this. It's going to be a lot more for sure. All right, yeah, we do have now 21 critical alerts. Defenders will be like all over your business right now after this. Specifically for the system user, we generated these 5 here. Malicious detection. What is this one? Behavior, potential execution via Sliver framework. Specifically, we had the process conhost.exe. So again, this is what we did here. Identifies the execution of commands via Windows PowerShell with a pattern specific to Sliver framework, mostly because we ran the execute and also we did not use any buffs. So of course we span conhost.exe and this is heavily signatured. And by the way, I did not do anything fancy to Elastic-SIEM. I just deployed the generic one, just like what I showed you in that video. Okay, so this definitely gets caught. Let's look at this one here. PowerShell again. We did not touch PowerShell directly, but when you typed interactive, we're actually getting into a terminal, and that terminal definitely brought us into PowerShell right here. Underneath me, you notice that it says PS. That's the PowerShell that they're talking about there. Like, hey, somebody launched PowerShell. It's because you went into interactive mode by running the shell command. And a lot of real attackers out there, they don't care. They'll run those commands if they want an easy payday. So defenders will definitely be catching that. What else did we see? Malicious detection. All right, here's our backup. We executed this backup here. The username was system. This is probably from when we used the last one. Malicious behavior again. Oh, print spoofer. Of course, print spoofer would trigger this. Generates a detection alert each time an Elastic Endpoint Security receives this case malware intrusion detection event process print spoofer.exe parent process PowerShell, because we executed it from that, by network system. Oh, that is a dead giveaway. Network system service is now running PowerShell, and specifically it's running print spoofer. That's a trend that is super simple to put 2 and 2 together. But this is also heavily signatured for Sliver framework. Otherwise, there's a lot of alerts here. This is beginning to be a long video, but the main goal here is if you do something like what we have been learning from all these hack the box and machines, this is what you see on the other end. And for years, I've made videos on this channel just grabbing flag after flag. And this is a change in pace where I want us to see how do we detect what we have been learning in these CTFs. And if you are going to be somebody who is going to work as a pen tester or red teamer, what will get you caught if you just go and borrow print spoofer online? If they have EDR in place, you most likely won't be even able to get execution on the system. Half of these would have been stopped. If I didn't turn off intrusion prevention, this would have been stopped. I would not even have gotten a shell. But of course, we did this. So this is where we end today's video. We were able to get a flag from the first machine. This is the SQL machine. And in the next future videos, we'll now move from this SQL machine. So next video, we'll start from here. Now that we're on this SQL machine, we're going to dump all the users, identify which of those users can get us access to the domain controller, and then we'll do our lateral movement. And then, of course, during this process, we'll watch our intrusion detection system to see if it can identify persistence and lateral movement. So the next video, I'm going to gain persistence here so that this machine can keep giving me my shell back. Then after that, we'll do dumping the password hashes. And after that, we'll do some lateral movement and do some AD attacks that way as well. Otherwise, thank you for watching, and I hope you enjoyed this. Let me know in the comments if this is something that works. These videos are getting to be longer and they take time, so please let me know if this is something that you're interested in by liking the video, subscribing to the channel, and we'll definitely finish this series if I see more interest.